Question number 1 states that if the vessel in the sample problem at the top of the page accelerates for 1 minute, what will its speed be after that minute? Now in the original problem, it was starting from rest, 0 meters per second as its initial velocity. We're looking for what the final velocity will be after a time of 1 minute or 60 seconds. The acceleration that it was given in the problem was 1.8 meters per second squared. So make sure you write this down. Question number 1, time is equal to 1 minute or 60 seconds. Acceleration is equal to 1.8 meters per second squared. Initial velocity is equal to 0 meters per second or rest, and we're looking for our final velocity. The equation we were using, acceleration is equal to delta V over t, or our change in velocity over the time, final velocity minus initial velocity, of course can be rewritten by using algebra or simply by using the equation that we had from Tuesday, or if you look in the book, the equation. Our final velocity is equal to our initial velocity plus the acceleration times the time. Now don't forget, if our initial velocity is 0, then obviously our final velocity is just the acceleration times the time. This should help you get the first part of our answer, which is in meters per second. Since we converted 60 seconds, we have meters per second squared, and we have 0 meters per second here. Just by plugging in our 1.8 as acceleration and 60 as seconds, we should get our final velocity, which you should be working on right now. So let's see, 60 times 1.8 equals, anyone? Okay, good. Now the second part of it is we need to take this number, which was given to us in meters per second, and convert it to kilometers per hour. Since it's already in meters per second and now we're converting it to kilometers per hour, what we're going to do is we're going to use the conversion factor of 3,600 seconds in 1 hour times our 1 kilometer is equal to 1,000 meters conversion factors to give us a final answer. Keep it to yourself when you get it in there. Problem number 2 states that in 1935, a French destroyer, La Terrible, attained one of the fastest speeds for any standard warship. Suppose it took 2 minutes at a constant acceleration of 0.19 meters per second squared for this ship to reach its top speed after starting from rest. Calculate the ship's final speed. Once again, we're looking for our final speed or final velocity. We've been given an acceleration of 0.19 meters per second squared, 0.19 meters per second squared. And our time is 2 minutes, which we can convert right off the bat. 60 plus 60 is 120 seconds. Our initial speed, once again, 0 meters per second. So, going through all this, acceleration is delta V over t. Final velocity minus the initial velocity. Final velocity is equal to initial velocity plus our acceleration times our time. Once again, the initial velocity is 0. So our final velocity is simply our acceleration, 0.19 meters per second squared, times our time, 120 seconds. Anyone? Oh, keep it to yourself. Write it down. Make sure you have all of this written down on the sheet. All these steps are important. Iana Salvador of Italy walked 3 kilometers in under 12 minutes. Well, that's very good for him. Suppose that during 115 meters of her walk, I guess it's a lady, Salvador is observed to steadily increase her speed from 5.2 meters per second to 5 meters per second. How long does this increase in speed take? Or assuming that we have the same pace going on here, we have an initial velocity of 4.2 meters per second, and we have a final velocity of 5 meters per second over 115 meters. Our equations, we know that our average velocity is equal to delta t, or delta x over delta t. And we also know that the average velocity, when we have two velocities, is our initial velocity plus our final velocity divided by 2, taking the average of that velocity. All right? Seeing as we're given a distance and we're given two velocities at a constant acceleration, we can determine that our average velocity, vi plus vf, divided by 2, is equal to our distance over our time. Or, using algebra, once again, we see that they give us the equation, delta t is equal to 2 times x, divided by, flip it over, crisscross, vf plus vi. Taking our numbers, 115 meters for x, 5 meters per second for our final velocity, plus the 4.2 meters per second for our initial velocity, we can plug, chug, and crank out our answer. Go ahead. Take your time. Is everyone caught up with me now?